Up to now, we basically ignored variation in treatment effect over time. And let's see how that works out in practice. Consider the following example. The adoption of a new technology that supposedly increases productivity. Say that you work in this factory and you have been collecting data and you have a control plant and a treatment plant, so you implement a new technology in a treatment plant, and then your data look as follows. On the horizontal axis we have time, on the vertical axis the outcome, which is productivity. In the control group nothing happens. In the treatment group we see that productivity slowly goes up. So apparently it takes some time before the full benefits of the new technology are absorbed. i.e., the size of the treatment effect varies over time. And remember, why should this be the size of the treatment effect? Well, in the difference in differences approach, that's exactly what we do. And there's two important assumptions that should be met before we can actually go through this exercise. First of all, there should be common trends pre the start of treatment. Well, that's what we see, the productivity is stable. And secondly, something that we cannot see is that no other policies were instituted around the same time. And so the idea is that we changed this technology, but around the same time other things did not change. Otherwise it's difficult to attribute the change in productivity that we see here to this policy being the new technology. Alright, so if we report the average treatment effect, then it's going to be like this. So it's sort of the weighted average of those treatment effects over time. And what happens if we ignore this treatment effect? Well, in this case, actually, we only get an idea of what happens on average over the time that we have collected data, but not over a shorter period or over a longer period. And in this case, the effect of the treatment grows over time. The short-term effects are small, the longer-term effects are large. Let's go back to that slide. So, based on this experiment and based on the capping off the data collection at some point, you may actually conclude that the treatment didn't do much. In some cases, you may not even be able to reject the null hypothesis of no effect. So you may go back to management and say, we did not find evidence that the new technology had much of an effect on productivity. But that may be a consequence of the fact that it took a while before the full benefits of the technology were absorbed. And so in this first case, if the short-term effects look worse than the long-term effects, then that may increase the likelihood of a false negative. So you're not able to reject the null hypothesis of no effect, even though there is an effect. It may also be that the short term looks better than the long term. That was the case in the examples that we discussed in the introduction. For instance, that may hold for some of the nudges. It may hold for some psychiatric drugs. It may hold for taking antibiotics. In that case, actually, there's a greater likelihood of a false positive. So we reject the null hypothesis of no effect, even though there is no effect in this slightly longer run, or the effect may actually be adverse. So we